Hello. This ERTMS ETCS Learning Module 2 is regarding the ETCS Level 2 operating modes. This is the part 1 of the 2 modules for the operating modes. The content of this learning module was prepared by Christopher Coe, and is presented with the voiceover, generated from the synthetic voice technology. This learning module explains the ETCS operating modes with scenarios and illustrations. The first 4 topics explain the driver-machine interface (DMI), ETCS trackside signs, ETCS operating modes, and the RBC and OBU data transmission. Then there is a topic explains the ETCS movement authority. After that, there are 4 topics explain the level NTCS N mode to level 2 FS mode transition, level 2 FS mode, level 2 OS mode, and level 2 FS mode to level NTCS N mode transition. ETCS Level 2 is an in-cab signaling system. Therefore, the instruction is presented on a driver-machine interface (DMI) on the driver's desk in the cab. The DMI for ETCS Level 2 operation provides speed and distance information to the train driver. The train driver operates the train based on the information. In contrast, the trackside color light signal provides route information to the train driver. The train driver interprets the information based on the route knowledge and operates the train speed accordingly. The DMI is an interoperability component of the Technical Specification for Interoperability (TSI). The TSI specifies the screen arrangement, size, symbols and colors. The ETCS DMI is located directly in front of the train driver in the cab, as shown in this image. Here is an example of the ETCS DMI when the onboard unit is in full supervision mode. The information on the left-hand side shows the current status of the train, such as the current train speed, the permitted speed, the ETCS level, and the ETCS operating mode. The information on the right-hand side shows the planning information ahead of the train. The right-hand side of the DMI is known as the planning area. Item number 1 in the image is the speed gauge in dark gray, indicating the maximum permitted speed. Item number 2 in the image indicates the current train speed in km per hour. Item number 3 in the image indicates the track condition information. Track condition information includes information such as raised pantograph, lower pantograph, tunnel, radio hole, neutral section, non-stopping area, new traction system, or sound horn. Item number 4 in the image indicates the track gradient information. The dark gray and the minus symbol means falling gradient. The light gray and the plus symbol means rising gradient. The gradient value means the rise or fall in every 1,000 meters. For example, the 13 in the dark gray bar means 13 in 1,000 falling gradient. Item number 5 in the image indicates the speed change within the movement authority ahead of the train. The pointing up triangle symbol means speed increment. The pointing down triangle symbol means speed reduction. Item number 6 in the image indicates the train position, which is at the bottom of the planning area. Item number 7 in the image is for displaying the geographical position information of the train in meters. Geographical position information is the track kilometer reference value that the onboard unit derives from the Belize telegram packet 79. Item number 8 in the image indicates the current operating mode. Item number 9 in the image indicates the text message from the radio block center. An example of the text message is the temporary speed restriction message. Item number 10 in the image indicates the status of the radio block center connection. In ETCS Level 2 operation, the gray symbol means the onboard unit has radio communication session with the radio block center. The red symbol means the onboard unit has lost the radio communication session with the radio block center. Item number 11 in the image indicates the ETCS operating level. Here is an example of the ETCS DMI when the onboard unit is in full supervision mode, and the train is near the start of deceleration location for the end of authority. The pointing down gray triangle symbol with 0 value indicates the end of movement authority. The white and gray square indication on the top left corner indicates the time to indication, TTI. The time to indication is the time to travel at the estimated speed for the remaining distance to the first indication location. The first indication location means the start of deceleration location, and is indicated with a horizontal yellow line on the planning area. Here is an example of the ETCS DMI when the onboard unit is in full supervision mode, and the train has reached the start of deceleration location. The start of deceleration location in ETCS is known as the indication location. Item number 1 in the image indicates the target speed monitoring. The speed gauge changes from dark gray to yellow when the onboard unit supervises the train speed towards the target speed. Item number 2 in the image indicates the target distance, which is the remaining distance towards the target speed location. Item number 3 in the image indicates the release speed value for the end of authority location. Item number 4 in the image indicates the target speed. For the end of authority location, the target speed is 0. The circular speed gauge and the speed pointer can indicate 4 colors: gray, yellow, orange and red. The gray circular speed gauge indicates the current permitted speed. The yellow circular speed gauge indicates the onboard unit monitors the speed reduction. The orange circular speed gauge indicates the warning for overspeed. The red circular speed gauge indicates the onboard unit has initiated the train brake after the overspeed warning. The color of the speed pointer indicates the current train speed, and corresponds with the color of the circular speed gauge. The train driver also receives audible information, in addition to the visual information on the DMI. When there is a new visual information on the DMI, the train driver receives a two-tone sound. In this example, the new visual information is the extension of the movement authority information on the planning area. Here is the two-tone sound to draw the attention of the driver. In this example, the new visual information is the indication for the speed reduction. Here is the same two-tone sound to draw the attention of the driver. When the train speed is above the permitted speed, an overspeed audible sound draws the driver's attention that the current train speed has exceeded the permitted speed limit. The OBU only plays the overspeed sound once, for each overspeed incident. Here is the overspeed warning sound to draw the attention of the driver. When the OBU activates the brake intervention, a continuous intervention audible sound draws the driver's attention that the intervention is active. The intervention audible sound continues until the train speed is below the permitted speed, and the intervention is released. Here is the intervention warning sound to draw the attention of the driver. There are trackside signs to facilitate the ETCS operation when the train is unable to operate in the full supervision mode. The ETCS stop marker is the sign with yellow arrow on the blue background. The ETCS stop marker aids the train driver to identify the end of authority, or the end of the interlocking route, during non-full supervision mode, when the end of authority is not indicated on the DMI. The train driver operates the train in level 2 shall not pass the ETCS stop marker, unless granted with a written order, and following the override procedure. The location of the police group with a stop if in staff responsible telegram packet requires an ETCS stop marker. The ETCS location marker is the sign with black arrow on the white background. The ETCS location marker aids the train driver to identify if extent of the track is free from obstruction, during the track ahead free request process. The start of cab signaling board marks the location with the Level 2 transition order police group. The end of cab signaling board marks the location with the Level L-NTC transition order police group. The km/h speed indicator provides speed information to the train driver when the track speed is below the ETCS non-full supervision ceiling speed value. The ETCS operating mode is an operating state of the onboard ETCS with a specified split of operational responsibilities between the onboard unit and the train driver. There are 16 operating modes available for ETCS. The first 2 operating modes are for this learning module. Full supervision offers the highest train protection when all the train and track data is available on board. The onboard ETCS is fully responsible for the train protection. The onboard unit enters full supervision mode when all the essential conditions are fulfilled. The train driver cannot manually select the full supervision mode. On-site mode enables the train to enter into a track section that is occupied by another train. The onboard unit enters on-site mode when all the essential conditions are fulfilled. The train driver cannot manually select the on-site mode. The onboard ETCS is responsible for the supervision of the train movement. The train driver is responsible for checking the track occupancy when moving the train. ETCS Level 2 full supervision operation requires data transmission between the radio block center, RBC, and the onboard unit, OBU. The data is essential for the safe train operation, and to indicate information on the DMI. These are the key data from the RBC to the train OBU via the radio communication session. The movement authority. The gradient information, the police group list, the permissible speed, the protected or unprotected level crossing, the track condition such as radio hole, neutral section, and traction power, the temporary speed restriction, the emergency message, the request to shorten the movement authority, the operating mode, and the RBC transition order. ETCS Level 2 operation requires two-way communication. These are the key data from the train OBU to the RBC. The train position, the movement authority request, the rejection or acceptance of the shorten of the movement authority request, the shunting mode request, the acknowledgement of the ETCS level transition, the acknowledgement of ETCS operating mode, and the end of mission. The train position data is critical for the safe train operation. However, the train position data from the train OBU to the RBC is not transmitted in real time. The train OBU transmits the train position data when start of mission. Time interval reached. Train passes a police group. Train stops. OBU changes operating mode. OBU changes ETCS level. OBU establishes communication session with RBC. And train passes border between two RBC areas. The movement authority is the permission granted by the radio block center for the ETCS on board, to allow the train driver to operate the train to a specific location, within the constraints of the infrastructure. The radio block center requires authorization from the interlocking system, before granting the movement authority to the ETCS on board. The route locking, route clearance, and route releasing are the features of the interlocking system, but not the radio block center. The speed profile, distance to go, and operating mode are the features of the radio block center, but not the interlocking system. A movement authority granted by the radio block center could cover more than one signaling block section, or an interlocking route. These are the common terminologies for describing ETCS movement authority in this learning module. The Technical Specification of Interoperability, TSI, subset 023, defines the meaning of these terminologies. The movement authority, MA, means the permission for a train to run to a specific location, within the constraints of the infrastructure. The end of authority, EOA, means the target speed is 0 at the end of the supervised route. The limit of authority, LOA, means the target speed is not 0 at the end of the supervised route. LOA usually is the level 2 to level NTC transition location. The supervised location, SVL, means the furthest point that a train shall not pass, either the EOA or the danger point. The danger point, DP, is the end of overlap, or the location beyond the EOA, that can create a hazardous situation. For example, the clearance point, the train overhang location, level crossing or trap point. The MA starts from the front of the train to the end of authority location. The MA does not reflect the same distance as the route locked by the interlocking system. The green color illustrates the distance locked by the interlocking system. The distance is from the preceding signaling block section to the end of the overlap location. The MA is from the front end of the train to the balise group that marks the end of the interlocking route. The end of authority is the balise group but not the ETCS stop marker. The onboard unit has the information regarding the end of authority balise group in full supervision or on-site mode, but no information regarding the ETCS stop marker. The SVL coincides with the DP location. The DP location is the location relative to the end of the overlap location, considering the potential train overhang length that is not detectable by the train detection system. Where there is no overlap section locked for an interlocking route, the locations for the EOA, the SVL, and the DP coincide with the balise group that marks the end of the interlocking route. This diagram illustrates the interlocking route for a train approaching a converging line. The MA is from the front of the train to the EOA. The EOA is the balise group that marks the end of the interlocking route. The location of the SVL and the DP is relative to the end of the overlap section, considering the train overhang length. This diagram illustrates two interlocking routes of two trains approaching the converging line simultaneously. The MA is from the front of the train to the EOA. The EOA is the balise group that marks the end of the interlocking route. The location of the SVL and the DP for the line on the top coincides with the end of phantom overlap location, or the clearance point. The location of the SVL and the DP for the bottom line is relative to the end of the overlap section, considering the train overhang length. This diagram illustrates two interlocking routes of two trains approaching the converging line simultaneously, when there is no overlap section. The location of the EOA, the SVL, and the DP coincides with the balise group that marks the end of the interlocking route. This diagram illustrates the interlocking route for a train approaching a terminal line. The location of the EOA, the SVL, and the DP is at the end of the line. The SVL location in the data may extend beyond the end of the line location, to enable the train to stop closer to the end of the line. This configuration is for accommodating the confidence interval. The MA can cover more than one interlocking route. This diagram illustrates the MA from the front of the train to the EOA, at the end of the two signaling block sections beyond the train. From the ETCS onboard perspective, the MA is a signaling block section. There is no information from the MA for the ETCS on board to discern the number of signaling block sections within an MA. However, the radio block center has the information regarding the number of signaling block sections for an MA. This diagram illustrates the Level 2 to Level NTC transition, from the mainline interlocking system to the depot interlocking system. The interlocking route from the main line to the depot line is the unproven route category in this diagram. The radio block center in this example has communication with the mainline interlocking system, but not the depot interlocking system. The balise group that marks the end of the route of the mainline interlocking system is the limit of authority (LOA). The end of the route for the mainline interlocking system is not the end of the route for the train path or the signaling block section. The onboard ETCS supervises the train speed, ensuring the train speed is reduced to the line speed at the boundary of the two interlocking systems. The train is not required to stop at the boundary of the two interlocking systems, thereby the location is a LOA, with the permitted speed above 0. The onboard ETCS supervises the EOA location based on the speed curve for the service braking distance, and supervises the SVL location based on the speed curve for the emergency braking distance. When the national value for the permission to use service brake data in the target speed monitoring is set to no, the onboard ETCS supervises the EOA location based on the speed curve for the emergency braking distance. The TSI default parameter is to use service brake data in the target speed monitoring. The movement authority process starts from the control system sends the route request to the interlocking system (ILS). The route request can be initiated by the signaler, or the automatic route setting system. The Step 1 item in this diagram illustrates that the interlocking route entry indication is initially in red color before the completion of the route authorization process. In Step 2, after the ILS locked and proved the route is clear, the route indication changes from gray to white color, meaning the route is locked. The route entry indication changes from red color to green color, meaning the route is proven clear. Step 3, the ILS sends the route authorization to the RBC. Step 4, the RBC generates the MA, and sends the MA message to the OBU. Step 5, after the OBU received the MA message, the OBU sends the MA acknowledgement message to the RBC. Step 6, after the RBC received the MA acknowledgement message from the OBU, the RBC informs the ILS. Step 7, the ILS informs the control system to indicate magenta color on the route entry, meaning the MA is granted and acknowledged for the interlocking route. The movement authority process is now complete. Next section will walk through the operational scenario for the transition from level NTCSN mode to level 2 FS mode during normal operation. Where the level NTC line connects with the level 2 line without trackside signal, the trackside infrastructure requires providing essential data to the train on approach to the level 2 transition order location. This diagram illustrates the train travels from the 3-aspect color light signaling line to the ETCS level 2 line without trackside signal. Signal S5 is the final signal for the 3-aspect color light signaling line. Usually, signal S5 indicates a proceed aspect when the track sections in the route are proven clear by the interlocking system. When signal S5 location is selected for the Level 2 transition order (LTO), for the line without signal, signal S5 only indicates a proceed aspect after the interlocking system has received the confirmation from the RBC that the onboard unit acknowledged the MA from signal S5 onwards. This feature is equivalent to the main aspect releases from the red aspect MAR control, with the MA acknowledgement condition, rather than the track occupation condition. Signal S5 requires TSS loop fitment to stop the train without ETCS on board continues the journey towards the Level 2 line without trackside signal. The OBU initiates the emergency brake if the train passed the LTO balice group without the MA from the RBC. The MAR control, the TSS loop and the LTO balice group safeguard the Level 2 line when the approaching train does not have radio communication session with the RBC. The start of the cab signaling board indicates the location of the LTO balice group, and there is no signal beyond the location. The session establishment balice group location is relative to the first caution signal of the final signal at the LTO location. The first caution signal for the final signal S5 is signal S4 in this diagram. The distance from the session establishment balice group to signal S4 requires 40 seconds for the ETCS on board to establish a communication session with the radio block center during the normal operation with a tolerance of minor irregular situation. The 40 seconds duration allows the ETCS on board to re-establish the communication session with the radio block center when the first attempt was unsuccessful. After 40 seconds, the ETCS on board will consider the session establishment process is unsuccessful. In addition to the 40 seconds, the distance between the session establishment balice group and signal S4 also requires allowances for the MA request time, system processing time, message transmission time, and the readable distance of signal S4. The distance between the session establishment balice group and signal S4 allows the train to maintain maximum permissible speed on approach to signal S5 during normal operation. This means the train driver will observe the green aspect on approach to the level transition order location during normal operation. The network registration balice group location is 40 seconds relative to the session establishment balice group location, to allow adequate time for the network registration process. The train with ETCS on board approaches the level transition order location, is in level NTCSN mode. The L-NTC indication on the DMI means the train is in level NTC, and can perform the transition from level NTC to level 2, when receiving the level 2 transition order. The octagon symbol on the DMI means SN mode. SN mode is only applicable to level NTC. There are two categories of level NTC for the GB main line application: L2NTC, and TPWS. The AWS indication is displayed on the planning area side of the DMI. When the DMI indicates TPWS instead of L2NTC, the train will not receive MA from the RBC, and will not be able to transition into level 2. The TPWS category of level NTC is usually for the train driver who has not yet certified for operating the train on the level 2 line. The train in level NTC is usually registered with the radio network. In certain situations, the train may have different radio network identifier stored on board, and cannot register with the radio network during the journey towards the level transition order location. Therefore, the network registration (NR) balice group provides the radio network identifier for the area. The OBU initiates the network registration process with the correct radio network identifier. If the OBU has not registered with the radio network, the OBU cannot establish the communication session with the RBC. There is no indication on the DMI regarding the train is registered with the radio network. The radio network registration for the OBU is similar to the mobile phone needs to register with a mobile network first, before making a phone call. The communication session between the OBU and the RBC is similar to a phone call between two mobile phones. When the train has passed the session establishment, SE Belize Group, the OBU initiates the communication session process with the RBC. The OBU obtains the RBC identity and the RBC telephone number in the Belize telegram packet 42, to establish the communication session. Upon successfully establishing the communication session, the DMI indicates the safe radio connection symbol, as shown in the amber circle on the image. After the communication session is established with the RBC, the OBU initiates the MA request process. When the OBU receives the MA, and the Level 2 transition announcement from the RBC, the DMI indicates the Level 2 announcement symbol, as shown in the amber circle on the image. At this stage, the train is still in level NTC and the final signal S5 is still indicating a red aspect. After the RBC received MA acknowledgement message from the OBU, the RBC informs the interlocking system. Subsequently, the final signal S5 changes from red aspect to green aspect, as illustrated in this diagram. After the train passed the LTO Belize Group, the OBU receives the telegram packet 41 from the Belize Group. The OBU changes the ETCS level from level NTC to level 2, and changes the operating mode from SN mode to FS mode. Item number 1 on the DMI indicates level 2 symbol, and item number 2 indicates FS mode symbol. The OBU requests the train driver to acknowledge the level 2 transition, by indicating a flashing yellow symbol, item number 3 in the image. The train driver has 5 seconds to acknowledge the level transition, before the OBU initiates the service brake. The circular speed gauge in dark gray, item number 4, indicates the maximum permitted speed. The planning area, item number 5, indicates the remaining distance to the end of authority or the stopping location. The train driver operates the train in level 2 full supervision mode, based on the speed and distance information on the DMI. The DMI will indicate speed reduction information in yellow color, when the train has reached the speed reduction indication location. Next section will walk through a degraded operation scenario, during the transition from level NTCSN mode to level 2 FS mode. In this hypothetical scenario, the transmission mast for the radio network coverage, on the approach to the level transition border, is offline. The ETCS on board, the RBC, the interlocking system, and the Belize groups are functioning. The train with ETCS on board unit on the approach to the level transition order location, is in level NTCSN mode. The L2 NTC on the DMI indicates level NTC, and the OBU can perform transition from level NTC to level 2, when receiving the level transition order. The octagon symbol on the DMI indicates SN mode. After the train passed the network registration, NR Belize Group, the OBU initiates the network registration process. The network registration process will be unsuccessful due to the radio network is offline. Without a registered network, the OBU cannot initiate the communication session process with the RBC, after the train passed the session establishment, SE Belize Group. There is no safe radio connection symbol on the DMI during the journey towards the final signal S5, when there is no communication session with the RBC. The train driver operates the train by observing the trackside signal aspect sequence. The train driver stops the train on the approach side of the final signal S5, indicating a red aspect. The OBU initiates the emergency brake if the train passed the LTO balice group without the MA from the RBC. The train driver contacts the signaller regarding the red aspect signal. The signaller authorizes the written order to the train driver to proceed via the degraded operation procedures. After the written order authorization procedure, the train driver selects EOA within the override menu to activate the override function. After the train driver selected the override EOA function, the DMI indicates the override EOA active symbol, as shown in the amber circle on the image. With the override EOA active, the ETCS on board will not initiate the emergency brake after the train passed the LTO balice group without MA from the RBC. The OBU receives the telegram packet 41 from the balice group after the train passed the LTO balice group. Packet 41 contains the Level 2 transition order. The OBU with the override function active will change the ETCS level from L-NTC to Level 2, and change the operating mode from SN mode to SR mode. SR mode stands for Staff Responsible Mode. The OBU resets the override function, and the DMI removes the override EOA active symbol. The specific transmission module, STM on board, which is the interface unit for the TPWS, changes to cold standby mode. The active TSS loop does not affect the train in Level 2 SR mode. Item number 1 on the image is the symbol for Level 2. The OBU requests the train driver to acknowledge the Level 2 transition by indicating a flashing yellow symbol, item number 2 in the image. The train driver has 5 seconds to acknowledge the level transition before the OBU initiates the service brake. Item number 3 on the image is the symbol for SR mode. There is no planning area, item number 4, when the OBU is in SR mode. There is no circular speed gauge, item number 5, when the OBU is in SR mode. The train driver is responsible for observing the track, and operates the train below the degraded mode operational speed. The OBU supervises the pre-defined ceiling speed of the SR mode. In Level 2, the OBU will attempt to establish the communication session with the RBC. For this hypothetical scenario, the radio network is online after signal S5. Upon successfully establishing the communication session, the DMI indicates the safe radio connection symbol, as shown in the amber circle on the image. When the OBU receives the MA from the RBC, the OBU changes from SR mode to FS mode. Item number 1 on the image is the FS mode symbol. The circular speed gauge in dark gray, item number 2, indicates the maximum permitted speed. The planning area, item number 3, indicates the remaining distance to the end of authority or the stopping location. There is no driver acknowledgement request for the FS mode, because the operating mode changes to the higher ETCS protection mode. However, the train driver receives an audible tone regarding new visual information on the DMI. Next section will walk through the scenario when the train diverts away from the level NTC to level 2 transition location. The LTO location in this example is on the approach side of a diverging junction. The level transition order is conditional. The balice group has a controlled or switchable type balice. The LTO balice group transmits level 2 transition order when the interlocking route is from S5 to S6. On the contrary, the LTO balice group does not order level 2 transition when the interlocking route is from S5 to S8. For color light signaling, signal S5 does not require MAR control for both routes with the same line speed. However, in this example, the interlocking system imposes the equivalent MAR control for signal S5 when the route is from S5 to S6, which is the ETCS Level 2 line without trackside signal. The diverging route from S5 to S8 does not require MAR control when the readability of the main aspect, and the junction indicator of signal S5 meets the requirement. A session termination release group is required on the diverging route to terminate the communication session with the RBC, when the train diverts away from the Level 2 line. In this case, when the route is locked from S5 to S8 and beyond, signal S5 indicates a green aspect. The train with ETCS onboard unit on the approach to the level transition order location is in level NTCSN mode. The L-NTC indication on the DMI means the train is in level NTC, and can perform transition from level NTC to level 2, when receiving the level 2 transition order. The octagon symbol on the DMI means SN mode. SN mode is only applicable to level NTC. The AWS indication is displayed on the planning area side of the DMI. If the OBU has not registered with the radio network, the OBU initiates the network registration process, after the train passed the network registration (NR) release group. Although the train path is towards the level NTC line, or the color light signaling line, the OBU still initiates the communication session process with the RBC, after the train passed the session establishment (SE) release group. Upon successfully establishing the communication session, the DMI indicates the safe radio connection symbol, as shown in the amber circle on the image. The RBC will not transmit a level transition announcement and the MA, because the route from S5 to S8 is not supervised by the RBC. There is no level 2 announcement symbol on the DMI. After the train passed the LTO release group, the OBU either does not receive the telegram packet 41 from the release group, or receives the telegram packet 41 with level NTC parameter. The DMI remains in the level NTCSN mode display. The OBU receives telegram packet 42 with the qualifier for terminating the communication session, after the train passed the session termination release group. Upon successful termination of the communication session, the DMI removes the safe radio connection symbol. Next section will walk through the full supervision mode, FS mode operation on the ETCS Level 2 line without trackside signal. FS mode is applicable to main class route, non-permissive shunt class route, warning class route, clear route, or the unproved route with limit of authority. During normal operation in Level 2 FS mode, the train driver operates the train by observing the permitted speed, and the distance information on the DMI. This diagram illustrates the MA from the front of the train to the S11 location. When the train reaches the location near to the start of the speed reduction location for the EOA, the OBU requests MA extension. The OBU will also request the MA, when the predefined time between two cyclic requests for the MA has elapsed. The MA request process is initiated by the OBU, and does not require any action from the train driver. As long as the route is locked, and proven clear beyond S11, the RBC will transmit MA to the OBU after the MA request. The DMI extends the distance in the planning area, and the train driver receives the two-tone sound for the new information. The target speed indication on the circular speed gauge remains the same, when there is no speed reduction. Next section will walk through the on-site mode, OS mode operation on the ETCS Level 2 line without trackside signal. OS mode is applicable to the calling on class route, the permissive shunt class route, the occupied route, or the degraded route. OS mode enables a train to enter an occupied track section. The RBC transmits the MA with OS mode based on the route category authorized by the interlocking system. The OBU requests the driver to acknowledge the change from FS mode to OS mode. The OBU is responsible for monitoring the dynamic speed profile, the permitted speed, the target distance to the EOA, and the target speed. The train driver is responsible for observing the track ahead is free, and stopping the train before the obstruction. This diagram illustrates train number 1 has the MA with FS mode towards S11 location. The train requires to stop at the station. The DMI indicates the permitted speed and distance relative to the EOA at S11 location. The train driver reduces the train speed for stopping at the station. The DMI indicates the speed reduction relative to the EOA at S11 location. There are two types of interlocking route from S10 to S11, clear route and occupied route. The signaler initiates the S10 route release request, so that an occupied route can be set for another train to enter the station. The RBC requests the OBU for withdrawing the MA. After the OBU confirmed the train is at standstill and acknowledged the withdrawal of the MA, the RBC informs the interlocking system, and the interlocking system releases the S10 route. Without the acknowledgement from the OBU, the S10 route remains locked. Train number 1 at standstill is still in FS mode, but has no MA. The EOA is the front end of the train. The signaler sets the S10 occupied route for train number 2 to enter the station, with train number 1 is still in the S10 route. The RBC generates the MA with two modes for the OBU of train number 2. The MA with FS mode covers the distance from the front of the train to the end of the section, which is proven clear by the interlocking system. The MA with OS mode covers the distance for the remaining distance of the S10 route, that is not proven clear by the interlocking system. The start of the OS mode location is the EOA of the FS mode. The DMI indicates zero target speed information relative to the FS mode EOA. The train driver reduces the train speed based on the indication on the DMI. When the train speed is below 40 km per hour, which is the on-site mode speed limit predefined in the national value, the DMI indicates a flashing yellow symbol. The yellow symbol is the acknowledgement for OS mode. The train driver requires to acknowledge the symbol for changing from FS mode to OS mode. If the train driver does not acknowledge the symbol, the OBU supervises the train speed to stop the train before the start of OS mode location. After the acknowledgement of the OS mode, the DMI removes the OS mode acknowledgement symbol, changes the FS mode symbol to OS mode symbol. The DMI also removes the planning area and the circular speed gauge. The OBU still supervises the EOA at S11. The train driver is responsible for observing the track ahead is free, and stops the train before train number 1. Train number 2 stops in the station within the S10 route, remains in OS mode. The OBU still has the MA with OS mode for the remaining of the S10 route. The S10 occupied route remains locked by the interlocking system. After train number 2 reported at standstill, route S11 is locked and proven clear by the interlocking system. The RBC transmits the track ahead free request and MA messages to the OBU of train number 1. The DMI indicates the flashing yellow symbol, requesting the train driver to acknowledge the OS mode request. The train driver requires to acknowledge the symbol for changing from FS mode to OS mode. If the train driver does not acknowledge the symbol, the OBU remains in FS mode. The train driver cannot move the train without the MA with FS mode profile. After the OBU changes from FS mode to OS mode, the DMI indicates the track ahead free TAF request. Train number 1 is on the track section that is not proven clear by the interlocking system. Therefore, the RBC requests the train driver to acknowledge the track ahead from the front of the train to the S11 location is free. The train driver may acknowledge the TAF request whilst the train is at standstill, or move the train until the track ahead free up to S11 can be ascertained. After the train driver acknowledged the TAF request, the OBU changes from OS mode to FS mode. The DMI indicates the FS mode symbol, the planning area, and the circular speed gauge. If the train driver does not acknowledge the TAF request, the OBU changes from OS mode to FS mode, after the train passed S11 Belize group. In FS mode, the train driver operates the train based on the speed and distance information on the DMI. When train number 1 exits the S11 route, the interlocking system releases the route. Train number 2 still has the MA with OS mode towards S11 location, but no MA beyond S11. When route S11 is locked and proven clear by the interlocking system, the RBC transmits the MA from S11 onwards to train number 2. Train number 2 is on the track section that is not proven clear by the interlocking system. Therefore, the MA with FS mode starts from the S11 location until the train driver acknowledges the track ahead is free upon request. When train number 2 reaches the track ahead free TAF area, the DMI indicates the TAF request. The train driver acknowledges the request, after the track ahead free up to S11 location can be ascertained. After the train driver acknowledged the TAF request, the DMI changes the operating mode from OS mode to FS mode. The DMI indicates the FS mode symbol, the planning area, and the circular speed gauge. If the train driver does not acknowledge the TAF request, the OBU changes from OS mode to FS mode, after the train passed the S11 Belize group. Next section will walk through the operational scenario for the transition from level 2 FS mode to level NTC SN mode, during normal operation. When the OBU is in level 2 OS mode or level 2 SR mode operation, the OBU changes the mode to SN mode, upon receiving the level NTC transition order from the Belize group. The level 2 line without trackside signal connects with the level NTC line fitted with trackside signals and TPWS, requires additional Belize groups, end-of-cab signaling board and the miles per hour speed board, to facilitate the transition from level 2 to level NTC. This diagram illustrates the train travels from the ETCS level 2 line without trackside signal, to the 3-aspect color light signaling line. Signal S22 is the first signal for the 3-aspect color light signaling line. The first signal and the second signal after the LTO location, to be the signals do not require TPWS-OSS fitment, to avoid potential conflict of permitted speed, between the ETCS and the TPWS. The level transition order, LTO Belize group location, is relative to the first signal S22. The distance from the LTO Belize group location to signal S22 provides adequate reading time for the signal. The end-of-cab signaling board location coincides with the LTO Belize group location. The MPH speed board location is relative to the LTO Belize group location, with adequate reading time. On the lower speed line, signal S22 is at a location so that the AWS is 5 seconds beyond the LTO Belize Group location. The level transition announcement, LTA Belize Group location is site-specific, allowing sufficient time for the train driver to prepare for operating the train based on trackside color light signaling. If the LTA is transmitted from the RBC to the OBU, there is no LTA Belize Group. The LTA from the RBC is typically transmitted together with the MA for passing the S21 location. The interlocking route from S21 to S22 should be a simple plain line area without speed reduction, neutral section, junction, station or level crossing. The RBC requires information from the interlocking system regarding the route status beyond signal S22. When signal S22 indicates a green aspect, the RBC generates the MA with the distance allowing the train to pass the LOA location, at the line speed. LOA stands for the limit of authority, which is the end of the ETCS supervision location with a target speed above 0. LOA location is the LTO Belize Group location. When signal S22 indicates a first cautionary aspect, the RBC generates the MA with the distance allowing the train to pass the LOA location at the line speed. When signal S22 indicates a red aspect, the RBC generates the MA with the distance relative to the red aspect signal. The OBU supervises the speed reduction towards the LOA. The train driver follows the speed reduction during the Level 2 FS mode operation, will have adequate distance to stop the train, when approaching a red aspect signal in the Level NTC SN mode operation. This diagram illustrates the route from S21 to S24, which is locked and proven clear by the interlocking system. The DMI indicates Level 2 FS mode, with permitted speed same as the line speed. The planning area indicates the remaining distance to the LTO location. The train driver can maintain the same speed, before and after the LTO location. After the train passed the LTA Belize Group, the DMI indicates the Level NTC transition announcement symbol. The OBU does not require any action from the train driver. The train driver is aware of the remaining distance, based on the information on the planning area. The LTA indication and the two-tone sound draw the train driver's attention, for final preparation to exit the ETCS Level 2 supervision. The OBU receives the telegram packet 41 from the Belize Group, after the train passed the LTO Belize Group. The OBU changes the operating level from Level 2 to Level NTC, and changes the operating mode from FS mode to SN mode. The OBU also changes the mode of the specific transmission module, STM, from hot standby mode to data available mode. STM is the interface unit between the OBU and the onboard TPWS and AWS. After 5 seconds, the onboard TPWS and AWS in data available mode is active. The DMI changes from the Level 2 display to the Level NTC display. Item number 1 on the DMI indicates the Level NTC symbol. Item number 2 on the DMI indicates the Level NTC transition acknowledgement symbol with flashing yellow. The train driver has 5 seconds to acknowledge the level transition, before the OBU initiates the service brake. Item number 3 on the DMI indicates the SN mode symbol. The planning area is replaced with the AWS indication. There is no circular speed gauge indication in SN mode. In Level NTC SN mode, the train driver operates the train speed based on the route knowledge, the trackside speed board, and the trackside signal aspect sequence. The information contained within this module was extracted from multiple documentation. The mandatory requirements and rules related to the operating modes are detailed in the subset 026, subset 035, and subset 093 of the Technical Specification for Interoperability. The subsets are available on the website of the European Union Agency for Railways. This brings us to the end of the ERTMS ETCS Learning Module 2. In summary, this module provides guidance and information regarding the movement authority, the driver-machine interface, the full supervision mode operation, the on-site mode operation, the Level NTC to Level 2 transition operation, and the Level 2 to Level NTC transition operation. Thank you for your interest and attention. Goodbye, and have a good day.